Okay, good afternoon, everyone. Welcome to today online tutorial. My name is Balaige Baradu, and I'm very happy that you're here. Please, if you are new here or you have not subscribed to this channel, I will beg of you that you should subscribe to this channel so that we can study together and get the best out of our study. Thank you very much. Now, let's look at what is before us today. Today, we are looking at the method of substitution in integration. The method of substitution in integration. And we have an example here. Example 1, they say that we should evaluate the integral of 8x times bracket open 3x square minus 7 bracket close raised to the power of 19 dx. How are we going to integrate this function? For us to be able to evaluate the integral of 8x times 3x square minus 7 raised to the power of 19 dx, let's look at how to integrate it. Given, we know that what we have here is the integral of 8x times 3x square minus 7 raised to the power of 19 dx. Now, for us to be able to solve it, we say that all this function, this particular function, which is 3x square minus 7 raised to minus 7 here in this, that is in this bracket, you say let it be u equals to u, let it be u, let this function here be u. So we say let u equals to 3x square minus 7. So that implies that the integral of 8x times 3x square minus 7, we know that 3x square minus 7 here, we say that let it be u. So we put u here in place of this 3x square minus 7 raised to the power of 19 dx. Now, what we are going to do now is that we are going to find the derivative of u. And we know that our u is equals to 3x square minus 7. So for us to find the derivative of u with respect to x, which is the x, we are going to have the u over the x. This du now simply means that we are finding the derivative of u. That's why we have this u on top of the denominator with respect to what? X. That is why I have the x here. So the derivative of u with respect to x, which is our u is equal to 3x square minus 7. So we are deriving this u with respect to x. So now we know that when we are deriving it, this power will multiply the function, which is 3x. So 2 times 3x raised to the power of 2, that same 2 here, you subtract 1 from the power. That means we use this power now to multiply the function, which is 3x. That is why these 2 come in front of this 3x by multiplying it. Then we still have the power of 2 here on top of the x. We subtract 1 from the power of the 2. That means in differentiation we are minusing what? 1. So we have the integration, the differential, the derivative of 3x squared is become what? 2 times 3x minus 2 minus 1 minus, when you derive a constant, is 0. So the derivative of this u will become what? 6x, because 2 times 3 is 6. Then we have x here. 2 minus 1 is what? Is 1. So 1 is to this power of x is the same thing as the x. That's why the u over the x become what? Equals to 6x. So in this case, we have 6x now, but we are not looking at the u over the x. What we are looking at is for how to get this, the x. So for us to get this, the x here, we, from this place now, we cross multiply to make the x the subject of the formula. So when we cross multiply to make the x the subject of the formula, we are going to have you know that the integral of 8x u raised to the power of 19 dx. Now we are going to look at this dx. So from this place here, this du over the x equals to 6x. We make the x the subject of the formula from this du over the x equals to 6x here. When we derive the u, we want to make this the x the subject of the formula, so we cross multiply. So the x times 6x is going to give us the x 6x equals to the u times 1 here is going to give us the u. So now anything that attached to the subject of the formula will come down to divide. That's why our the x now become what? The u over 6x, because this 6x now divides the u that is on our right hand side. Now we know that the value of the x now is what? equals to du over 6x. So from this place, from this particular point now, we have already gotten the value of the x. So let's substitute the value of the s in this place. So that is why I have from the integral of 8x times u raised to the power of 19 that we have on the front here. Now that this is the x now, this is the x here, this is the x we have here. We substitute with the u over 6s because this is the value of the s is the u over 6s. So we multiply it by this integral 8x times u raised to the power of 19. So now we know that the integral of 8x times u raised to the power of 19 times the x, this is the s now, we substitute what the u over 6s because this is the value of the s, the u over 6s. So we know that in this 2 going to this 6 how many times? 3. Then 2 going to this 8 how many times? 4 times. X cancel x, so we're going to left with the integral of what? 4 times the u raised to the power of 19 that we have here, because 4 will multiply this function here, which is u raised to the power of 19 times, here we're going to left with what? The u over 3 that we have here, the u over 3, because this s already cancel, the u over 3. So let's continue. Now we have the integral of 4 times the u raised to the power of 19, the u over 3. You know that this is all over 3, so it's the same thing as 4 all over 3 times u raised to the power of 19 du. In integration, we put the constant outside before integrating. So this 4 over 3, we multiply the integral, then we integrate u raised to the power of 19 respect to du. So we're going to have, you know that in integration, let me just say this is u, right, as the function. This symbolize u, the function. We're going to add the power with plus 1, then also divide with n plus 1. That is how I used to do integration when integrating integration. So we're going to have this 4 all over 3 here times, we have 19 here, so 19 plus 1 is going to give us what? 20. So also divide it by 19 plus 1, then introduce a constant which is plus c. So we're going to have 4 all over 3 times u, which is our function, this is power of 20 all over 20 plus c. Here we know that 4 can go here 1, 4 can go here 5, to make the thing be more simple in a simple form. So we are going to have 1 all over 3 here times u raised to the power of 20 all over 5 plus c. And we know that 3 times 5 is going to give us 15. U is going to give us 15. That is why I have the function u raised to the power of 20 all over 15 plus c. And we know that our u was equal to what? 3x squared minus 7. So we substitute this value in place of our u. That is why this function u raised to the power of 20 all over 15 becomes 3x squared minus 7 all over minus 7 raised to the power of 20 all over 15 plus c, which is our constant. And this is the final answer. So thank you very much. If you have any question concerning this online tutorial today that we talk about the method of substitution, you can drop it in the comment section. And please don't forget to subscribe. Thank you very much. I'm really happy that you are here. God bless you.